Hey everybody, it's Monty, and here we are. Finally, we're done with triangles. 3 months of triangles. I think we're done with that. I think it would be cool if we started to think about circles and shapes and volume and surface area. Okay? And when we do that, we think about circles first. Okay? The wheel. Who invented the wheel? All right. So we're on week 32. It's May 9th and 10th. Let's say 6 weeks of school. We're going to work on circles for 3 weeks. Circles, volume, surface area. And then we're going to go into probability. And Mr. Miller's got decks of cards and dice for all of you individually so that we can figure out the probability. Okay. Let's get started on this new module, this new topic, circles and shapes. There's a cheat sheet coming. Mr. Miller's got a 2-page cheat sheet to hand you. You won't have to look in your mailbox. You're going to get one right in your hand. Okay, why do we study circles? The universal tool for this module. Serious, every year, everybody gets their own toilet paper roll. And you notice I left a little so that you didn't think I'm making this up. It's a toilet paper roll. Okay. With any new module, with any new topic, boy, do we have vocabulary. What? You know these terms already? This is so much fun now. Okay. I like to call this particular day out with the old, in with the new. Okay, so let's move me here and put me over here, and out with the old, in with the new. Okay, so what does that mean? We never did this in the actual online because, I don't know, it's just kind of weird. But now that we're back in the classroom, serious, we want to put away the old stuff and get ready for the new stuff, okay? So, literally, go through your folders, look at all this stuff we've accumulated, right? And I would get rid of everything but the important notes, okay? So, by important notes, there's a cheat sheet. That cheat sheet is basically everything you should take with you to your next math class. Okay? So, pause the video. You as a class, look around. If you need folders, ask Mr. Miller, because I think there's extra folders in the cabinet. There's also a recycle bin up front. You don't have to keep that stuff, not unless you want to. The beauty of this hybrid learning is all of your assignments that you have to have are on teams, and they're not going anywhere. Okay, so, again, pause the video, out with the old, in with the new. Keep the cheat sheets, and prepare for the new circles. Okay, ready? Out with the old, in with the new. And Mr. Miller has handed you a cheat sheet, okay? So let's just take a moment and look at the new cheat sheet. And you're going to notice we need to know something about circles. We're going to have to remember some of our vocabulary. Do you remember central angle? Okay. Do you remember circumference? Okay. Do we remember R for radius? Okay, now, new terms. Radian measure? Arc length? What? Formulas? You mean like old-fashioned math? Okay. We want you to take notes in this section. This is where we're headed for next week. Sector area. This is where the formulas come in. The area of a circle. But what if we don't want the whole circle? We only want a piece of the pie. Now we've all either had pizza or pie, and they come in wedge shapes. We want to be able to calculate the length of that edge or the area of that piece of pie. And we're going to be doing that. Okay? All right. Now flip to the next side and you're going to see volume. Okay? This is when we take you from two-dimensional math. Your entire math career you've been doing 2D, X and Y. Now we want the third dimension, X, Y, Z. Length times width times height. Okay? And those are the basic shapes that we study. Then, we're not going to really have time because we're only going to do this for 3 weeks, but the surface area. Okay, we want to be able to calculate, if we unfold this, how much surface area does it include? Okay, and there's formulas for that, a little bit more math. And then, in a perfect world, we want to be able to visualize cross sections. And again, we probably won't have time for this either, but it's neat to have. Okay, so you've got a cheat sheet. 4 pages front and back. So 2 pages stapled front to back. Okay? All right. Now, before we get started, in the textbook, and this is going to be on page M422. M422. So let's just write that. M422. Okay? And again, it's a strange year. This textbook, we really haven't opened it. There are some cool things in the book, but the book doesn't really fit hybrid learning 2 days a week, so we haven't used it much. But if you have the book, I would tear this out because this is an unbelievable page. What? How do I know it's an unbelievable page? What's this over here? How many of you have ever ridden a Ferris wheel? Okay, again, pause the video, share in the classroom. How many have ridden a Ferris wheel? Okay, over at the fair here in Spokane, over at the fair in Seattle. The fair over in Coeur d'Alene. Now, across the country, they're building these super wheels, these giant ones. Have you ever ridden one of them? Okay, so I'll see you in a minute, have a discussion, look around the room, share out. Okay, see you in a minute. All right, welcome back. Now, again, we're not in a hurry. We're wrapping up the year. We want to have some fun, and there's nothing more fun than real-world math in our world. Okay? I have actually been to the Ferris wheel in Seattle, and it's a math problem. Serious. For those of you going to Algebra 2, you spend like 3 weeks on these type of problems. And they're called sine curves, periodic functions, waves, right? The tides. The motion of a Ferris wheel needs to be modeled mathematically. That's why we do math, remember? We're trying to describe the world with numbers. Without further ado, let's go check out this video. So I got to hit here, and I got to hit, yeah, this is in the way, isn't it? All right. Let's pull this over, and there we go. Boom. Okay, we're going to pull this video up, and we need to change that. Change that. I wasn't prepared. Okay. All right. Wow, I know that guy. Looks a little skinnier than me. Okay. Here we go. Let's watch this video and the Great Seattle Wheel. Lonnie here. I just bought my $13 ticket for the Great Seattle Wheel. Your job is to model my motion as I go around the Great Seattle Wheel 3 revolutions in 15 minutes. Remember, the diameter of that Ferris wheel is 175 feet. Graphically represent my motion as I go around the wheel 3 times, and then at the end, state how far I actually traveled. Whoa. What is he talking about? 3 revolutions. There's a new vocab word. Distance traveled. We're not traveling distance. We're going around in a circle. 3 revolutions. Distance around. Whoa. There's so much new vocabulary. Okay, so notice how my head's always in the way? Okay. All right, so we got a lot going on. We got distance around. We got these gondolas. A Ferris wheel 50 meters. He said a different number. Oh, this is getting confusing. All right. We're going to come back to the video in a minute. But before we do that, okay, let's take a look at this universal tool, the toilet paper roll. Now, we don't have enough toilet paper rolls, but we have paper towel rolls. So at this time, again, pause the video, and Mr. Miller is going to hand out toilet paper rolls, the universal tool for Module 4, Topic 1. When you get your tool, trace the diameter of the roll. Trace the diameter of the what? What's he talking about? All right, so pause the video. Everybody get yourself a tool. All right, welcome back. Trace the diameter doesn't sound right, does it? We want to trace this circle in our notes, okay? So we're going to go back to our note page. There it is. We want to trace this right here, okay? All right, so I'm just going to put a circle right here. And we don't want to be perfect. We just want to trace it, okay? Circle. All right. Now, in a perfect world, I set this on the screen. As a matter of fact, I wonder if I could do that. Can I do that? Never thought of that. Let's try that. Never sketched on. Okay. Bear with me, class. All right. Now, we need to measure this. Now, depending on how the class is going and if Mr. Miller has time to hand out the rulers and all that stuff, we're looking for that distance R. Serious. That's our goal. We also need the circumference, the distance around. We need the diameter. We need the radius. Okay? All right. Well, if we have one, then we have all the others. I'm going to Google the average toilet paper roll. Toilet paper roll diameter. Okay? And the average measure of a modern toilet paper roll is 10 centimeters, 3 15/16 inches wide, 12 centimeters in diameter for the average measure wide for in diameter and weighs. Diameter. Okay, right there. 12 centimeters, 4 23/32 inches in diameter. So 12 centimeters or 4 let's check that out, 23/32. 23/32. 23 divided by 32, 0.7. 4.7, 12 centimeters. Okay, 4.7. 4.7 Okay, we need the roll. Toilet paper roll. We don't want this. We just need the cardboard cutout part. Yeah. Alright, so let's go here. And toilet paper roll. Okay, dimensions of the cardboard toilet paper roll. Diameter. That's not going to help. Okay, so this is harder than it looks. How about the length of a toilet paper roll? Length, toilet paper roll. Length and diameter of a toilet paper roll. Width, diameter, circumference. We just need the cardboard part, huh? Alright, so in your class, feel free to pause the video and look. I'm going to just use, okay, remember this tool from the other day's video? Okay, I'm just going to use this, and we're going to go 1.7 across. So let's go 1.7 across. Okay, alright. So our toilet paper roll will go 1.7 across. So the diameter is 1.7, and the radius will be half of that, 0.85. So 1.7 and 0.85. Okay, now we need the length. Okay, so sketch the length here. Okay, so if I come over here and I put a little mark, and I come over here and I put a little, oh, it's going to hang off the edge. Okay, now sketch it. Okay, how'd they get the letter E? Oh gosh. Okay, so now I'm just going to sketch this thing. Boom, boom, and then so that it kind of looks circular, right? And then dot, 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 dot. Okay, now I need the length, and with our tool again, boom, boom. Ooh, right on 4. All right. So now the length. You guys any good at three-dimensional objects, right? And then down here we got to make that dotted, right? This is a great time to practice sketching three-dimensional objects, right? Tin can, cylinder, right? And the length will be 4 inches. So now we've got 4 inches long, 0.85 is the radius, the diameter. So now we can do circumference. The circumference, C equals 2 times pi times r. The distance around. The distance around will be C equals 2 times pi times r, 0.85. Okay? And that'll be what, 1.7 pi. And just so we get our calculations, we have a pi button. My head is in the way again. Okay, so now we have 1, actually let's just do the whole formula, right? 2 times r, 0.85 times pi. Alright, 5.34, okay? So, the distance around, 5.34. 5.34 inches is the distance around our roll. Now those of you that have paper towel rolls, I didn't bring one, okay? So the paper towel roll is going to be different. So we're going to have 2 different measurements, okay? And next time I'll bring that so that for the rest of the next 3 weeks, we're all using the same numbers, okay? So if you have a TP roll, 5.34 is the distance around, otherwise known as circumference, and the length, okay, our length will be 4 inches. Now, sometimes in our formulas, they call that the height, the length, the width, the height, okay? So on our notes here, just put that's equal to height also, all right? Height, all right. So we're 20 minutes into class. We had a pause for out with the old, in with the new. We had a pause for the video on the Ferris wheel. And we've had a pause because we've been drawing and sketching. Now, we want you to decorate the room. What? During hybrid learning? Take some tape or thumbtacks, push pins, and hang them around the room. So now what you need to do is find a way to mark your toilet paper roll. Okay? So I'm just going to write Monty. Monty. Okay? And now that I got Monty on there, with distance learning, social distancing, we need to get a piece of tape and we need to hang these around the room. It would be cool to see the room after we do this. I love doing this every year. So I got my tape, I got my roll, and I'm going to hang it right here on the edge of the board. Boom. Okay, and I'll get a paper towel roll for next time. If this is all we accomplished today, there's nothing wrong with that. Because our first lesson in circles is right here. Circumference and angle measure. How many degrees in a circle? 360 degrees to go around our toilet paper roll. And then we remember half a circle is 180, right? Cool. All right. So feel free, if this is all we accomplished on this week, we went out with the old, in with the new. We saw Monty on a Ferris wheel and the Great Seattle Wheel and all this new stuff about distance around and angle measures and what's he talking about? And we're going to learn that. Now, here is where we want to start with. The Ferris wheel is 50 centimeters tall. The actual wheel constructed with steel arcs and connected that connect one passenger car to another passenger car. All right, so before we go on to this problem and talking about this, pause the video and everybody clean up the room so when the bell rings you can just leave and not have to worry about where you stored your toilet paper roll. See you in a minute. Okay, welcome back. On this next item, we need another piece of paper. Mr. Miller is going to hand out a sheet of paper that has this Ferris wheel and the We Do for notes. Okay? All right. So that'll be the next video. If you guys finish this much and you want to get started on the Ferris wheel problem, feel free to do it. Otherwise, we'll see you on Wednesday, Thursday, where we talk about how to answer these problems. The distance around, connecting the passenger car, the length of each steel arc connecting one passenger car to another. Okay? So, and then we'll talk about angle measures. See you next time. Have a great week, everybody. Welcome to May. We're done with triangles. I hope you're excited. We're excited because real world math. And this Ferris wheel. Bye.